In this lesson, we will learn how to represent an AC phasor with complex numbers. AC signal, AC means alternating current. When the signal varies from positive and negative, we call this an alternating signal. Example of an AC signal is a sine wave. Okay, sine wave, it varies from positive and then negative and it keeps changing. To represent a sine wave, we can represent it with this equation. Okay, this equation. Here it shows the signal changing with time. Okay, and this AM is the maximum value. This value basically. Okay, this value is your maximum, the peak value of the sine wave. This is AM, and then you put sine to indicate it's a sine wave. And then we have omega. Omega is called angular frequency. Okay, angular frequency. It's basically you take the frequency, the normal frequency, and you multiply by 2f. Okay, omega is 2 pi f. How to get the normal frequency? The frequency is just 1 over the period. Period is the time from here to here to complete one cycle. Okay, so if you take the time here to here, this is one period. Then we take the invert of the period, 1 over the period, we get the frequency, and then multiply by 2 pi, we get the omega. So this is just 2 pi f. Okay, then you multiply the t. Then we have this. This is called the phase angle. Phase angle shows how much the wave is shifted to the left or right. In this case, it starts from this point. So the phase angle is 0. Okay, this is plus 0. We don't need to write if it is 0. But if the wave is shifted to the left, if it starts earlier, then we say it has a positive phase shift. Okay, so this is the angle here. For example, this could be around 20 degrees. So here you put plus 20 degrees. If the wave is shifted to the right, okay, it starts later, you see, it starts later than this, then we call this a negative phase shift. So this one will have a negative angle. Okay, this will be like minus, maybe this is, let's say this is negative 30, then this is minus 30 degrees. Okay, so these are the important parameters in a sine wave. AM is the peak value. Okay, the peak value here, and then the phase shift, this symbol, the phi here indicates the phase shift, and then we have the omega. Omega is the frequency, it's related to the frequency. Okay, now this is one way of representing the sine wave to write the complete equation. We can also represent this waveform in a simplified form. This is called a phasor diagram. How to draw a phasor diagram? It's very simple. You just look at the angle. If the angle is 0, then the arrow is just at this. Okay, you write the arrow at the 0 angle like this. If the angle is positive, then we draw the arrow on top. Okay, and we indicate the angle here. For example, in this case, it should be about 20 degrees. If it is negative, then we put the arrow down and you indicate the angle here. Okay, so these are the ways to draw the phasor diagram. Okay, the third thing is we can also represent this sine wave in a complex format. This is called complex representation. Okay, it's a very straightforward conversion. We just take the peak value, divide by square root 2. So this is the RMS value of a sine wave. It's given here also. You just take the peak value, divide by square root 2. Then you put this symbol. This is the angle symbol, like this. Then you write the angle, the phase. That's all. Okay, I'll show some examples here. It will make it much more clearer. We see here, this is a sine wave. The maximum value is 15 and the phase is 0. Okay, So if you want to represent this in a complex format, it's very simple. You take the 15, divide by square root 2, then you put this symbol, write 0. Okay, that's all. 15 divided by square root 2, if you calculate, it's about 10.6. Same thing here, 18, the face is 40. So you take 18 divided by square root 2, which is 12.7, and you put the angle 40. Okay, this is 10, the angle is minus 35. So 10 divided by square root 2 is 7.07, and then we put the angle. That's all. That's all the way to represent a sine wave in a complex form, a complex representation. Thank you.